Hi Wildcats, this is the pre-lab video for the Unit 2 Focus Question 6 lab on refraction. So there are a couple things you'll need to do the lab. I'm going to show you how to do it and give you some sample data on using water. You'll use an unknown substance, and ultimately both my goal in this lab and your goal when you do this is to determine the index of refraction for the substance in the semicircle dish. So the things that you'll need are this lab refraction template, marking utensil and a protractor. You'll also need a laser, and then you'll need a semicircle dish, and then it'll have the, for you, unknown substance inside of it. So the way that this lab sheet works is you will put the semicircle dish here, and then using these lines, you'll shine the laser along these lines, and so this is our angle of incidence. So this is 0 degrees, this normal line is 0 degrees, and then we'll put the laser, shine the light or laser in through angle A, B, C, D, E, F. And each one of these are a different angle, and then we know that when light or electromagnetic waves travel through a medium, they slow down and therefore they bend or refract. And so our goal will be to see where they come out and mark it on here. Then we'll be able to measure the refracted angle away from this line, and using our known incident angle and known refracted angle, as well as the index of refraction for air, which is traveling throughout here, we should be able to use Snell's law to determine the index of refraction for this unknown medium. We'll end up doing that by creating a graphical and mathematical model, and I'll have a separate video on that. I just wanted to show you how to run this lab. I'm going to do this with the lights on, but when there's a whole bunch of students in here, we'll have the lights off. So the very first step you want to do is to take your sheet, your refraction lab blank, and put it on the table, and then take your semicircular disc and put it right along this center line. So now I can shine my laser in through here. It'll go through the water and then come out and refract somewhere along here. So you'll have laser pointers for this, and it'll also be easier when you have two people. One person will end up working this laser and shining it through, and then the other can mark it. So a few tips, you kind of have to do some estimating or do your very best to get it along this line. What I found to be helpful is if I point the laser, so I'm not sure if you can see this on the camera, but my dot is right here, and then I just slowly lower this so that it follows the line, because my goal is to go in as close to that angle as possible. And then it shines out, and so for me, it's lined right here, so I would take my pencil and mark right here, and so then I could take this and label this A. So this point, this line right here, is the refracted angle when the incidence angle is here. And then I'll repeat that for B, and then so that goes in, and my partner would be marking while I trace this line with the laser. So for me, B is right here, there. Put a little straighter, and then put B. And then I would continue on, right? So C, D, E, F. And when it's all said and done, what you'll have is a whole bunch of marks over here. And so then what you also need to do is, first I need to know what are the index or the incident angles. So I would take my protractor, put it on this line, and measure where it comes out. So if this is I've got it here and here, it's perpendicular. So this looks like it is angle A, the incident angle is 9 degrees. And so that would come over here to A and do the same thing. So this to me looks like it is, so at A over here, this is 7 degrees. So now I have my incident angle as 9 degrees and my refracted angle is 7 degrees. I would do the same thing for B, incident and refracted, C, incident and refracted, all the way along. And so then what I'll end up with is two columns that I can graph. My independent variable, what I'm changing, the incident angle, and my dependent variable, the refracted angle, and then I can do a couple different things and get the graphical and mathematical model to basically give me the index of refraction. So I'll have a second video on that, on how to use Google Sheets and some formulas to save yourself a whole lot of time. Although you can also just use Snell's law and do the hard math, or not the hard math, but the long math to figure out the index of refraction as well. So I hope that helps. Again, when you do this lab, you won't be using water, you will be using some unknown material. And from there, you can use this procedure to determine the index of refraction for that unknown material.